You know that box in your kitchen? The one that reheats last night's pizza in, what, 2 minutes flat? It feels like straight-up magic. Well, today, we're going to pull back the curtain and look at the incredible physics that makes it all work. Let's demystify that magic box, shall we?
I mean, that's the real question, isn't it? There's no open flame, there's no glowing red part like you see in a toaster. You just put your food in, you push a button, and a minute later it's piping hot. So what in the world is going on inside that humming machine? Let's figure it out.
So to kick things off, we need to tackle the single biggest misunderstanding people have about microwaves, this idea that the oven itself is what's creating the heat. Okay, get this. The microwave oven isn't pumping heat into your food at all. Nope. Instead, it's filling that metal box with invisible energy waves. The heat is just a byproduct. It's something that happens inside the food itself because of those waves. And that little fact right there completely changes how you think about this whole process.
All right, so if it's waves heating our food, the next logical question is, what kind of waves are we talking about here? This gets us right to the heart of why it's even called a microwave.
The secret ingredient is, you probably guessed it, microwaves. These are a form of electromagnetic radiation, which sounds a little scary, but they're on the exact same spectrum as the radio waves that bring you music or the visible light that lets you see this right now. They're all part of the same family, just a different frequency. And they are unbelievably specific. Your standard microwave oven operates at a super precise frequency, 2.45 gigahertz. We're talking 2.45 billion cycles every single second. Now, that's not a random number. That frequency is the perfect sweet spot for interacting with a very, very common molecule found in almost all food. But before we get to that, where do these waves even come from? To create waves this powerful and this specific, every microwave needs what is basically an engine. And the heart of that engine is a really cool device. It's called a magnetron. This thing is a brilliant piece of engineering. It's basically a high-powered vacuum tube that's designed to do one thing and one thing only: turn electricity into perfectly tuned microwaves. It's really the unsung hero of your kitchen. And how it works is actually pretty elegant. So first, a stream of electrons is released into a chamber. Then, a really powerful magnetic field grabs those electrons and forces them into a circular spinning path. It's this super fast controlled spinning that generates a steady stream of our 2.45 gigahertz microwaves. Okay, so we've got our waves, the magnetron is doing its thing. Now for the main event. How do those waves actually heat your food? Well, the answer lies in making the tiny little water molecules inside your food start a crazy high-speed dance. So you've got two key players here. On one side, you have the water molecule. It's what we call a dipole. Think of it like a tiny magnet with a positive end and a negative end. On the other side, you have the microwave, which is creating a rapidly flipping electric field. So what do you think happens when you put that tiny little magnet inside a field that's changing direction billions of times a second? Well, you get a process called dielectric heating. The electric field of the microwave yanks on those little water molecules, trying to make them line up. But because the field is flipping back and forth 2.45 billion times a second, the water molecules are forced to frantically spin, trying to keep up. All of this spinning creates a ton of friction between them and their neighboring molecules. And what does friction create? Heat, lots of it. That is how your food cooks, literally from the inside out. So let's put all those pieces together. Let's assemble this entire scientific puzzle for one final, crystal clear picture of what's really happening inside that box. And there it is. That's the whole story right there. It all starts with magnetism inside the magnetron, which directs electrons. Those spinning electrons create electromagnetic waves. The waves then travel into your food and make the water molecules dance. And that molecular dance party creates friction, which we feel as the heat that cooks our meal. It's just this beautiful, elegant chain reaction of physics.
So we've gone from a mysterious humming box to a clear chain of electromagnetic principles. It really makes you wonder, doesn't it? What other everyday magic in your home, maybe your Wi-Fi router or an induction cooktop, is just waiting to be explained by these same elegant laws of physics? Thanks for joining me.